Hello, Raymond and Jacob here, and we are doing a lesson on covalent and ionic bonds. Ionic bonds. Ionic bonds occur between metals and nonmetals. The transfer of electrons occur, and they are attracted by positive and negative forces. It is also the strongest bond.
Alright, so this is going to be the example of ionic bonds. We are going to be using lithium and fluorine right here. Fluorine has 7 valent electrons and lithium has 1. And this is the metal and this is the nonmetal that are, because ionic bonds only happen between metals and nonmetals. Basically what happens is lithium wants to give away its one valence electron in order to become a happy atom with a full ring and no extra on its valent. And fluorine wants to become happy when it has ring fully full with valent electrons. So basically, what happens is lithium just gives its valent electron over to fluorine, which basically when this comes over here they become bonded together, and that is how you get your ionic bond.
Covalent. Only occur between two nonmetals. Sharing of electrons occur, and two atoms sharing electrons.
Alright, this is going to be the example for the covalent bond. It happens when you have two nonmetals. We have hydrogen, both hydrogen here, and it happens when each of these atoms want to get the valence electrons from the other atom. So both of these, we are on the first ring of electrons, and both of the rings only have one valence, and in order for this ring to be happy it needs two electrons. And so this one wants this one and this one wants this one right here. But in order to do that they can't just take them, because then it won't have any electrons. So instead what they do is they combine like so, and then they both just share these electrons. And that is how a covalent bond forms.
Valence electrons. Electrons in the outermost shell. Only electrons used in bonds. Polar covalent. Three or more atoms sharing electrons.
Okay, this is going to be the model of the polar covalent. We have oxygen here. This is the easiest one and most widespread that you'll probably see. And we have our two hydrogen atoms here. There's not an H, but they're hydrogen. And what happens, instead of having this over here, where you have two hydrogens that bond together to fill the rings, instead they bond with an oxygen. So instead, they basically do the same thing over here, but instead of connecting to the other hydrogen, they connect to one of the oxygen's valence electrons, like so. And then it also happens over here. So now oxygen has all 8, and hydrogen has both of theirs. And this is a polar because you have 3 that are connecting, and not just 2 connecting directly to each other. There's 3 atoms connecting to each other in order to fill all of their outside rings.